Hi there, it's Hannah. I'm going to talk to you today about our two stacking blocks kits. On my left, we have our basic stacking blocks kit, and everything over here is the stacking blocks kit engineering expansion. Let's talk a little bit about what you can do with just the basic stacking blocks kit. The pieces all just slide one on top of each other like that, and you can then use it to build histograms, bar graphs, line graphs, flat histograms, stacked histograms, even use it as a way to do pattern recognition in elementary school. One of the best activities you can do with this kit is getting students to really start practicing and understanding mean and median. But if you were to say challenge your students to build a graph, and you could have a number line or something out, where based on the data you see, the mean and the median are both 7. You can challenge your students, now that you've found one way, find a different way. And then get them to start doing challenges where can you build a graph that has a mean higher than the median, or vice versa. And so then you can start getting into different distribution patterns. And maybe you'll have a skewed distribution rather than a regular distribution. So this is just a really good way for the students to start really understanding and quickly estimating what graphs mean in terms of mean, in terms of median, and other things like that, because they're actually interacting with the data itself. Combining multiple sets of the stacking blocks kit in more colors allows you to extend its purposes even further. And there's another really useful scenario where you would use multiple colors, and that is in compound frequencies, which is something you could do in a high school level. As you can see, the stacking blocks kit has a lot of really good uses from elementary all the way up to high school to get your students familiar with patterns, graphing, and understanding different things. But let's move from pure mathematics over to integrated STEM. That's where the stacking blocks engineering expansion really comes into play, because this is a kit that gets you to be thinking mathematically, scientifically, and like an engineer as you build and test your own structures. The plastic you'll find is remarkably sturdy, but what you can do is actually place this up against a wall or something, and then measure the displacement or the deflection of the bridge depending on the different weights. So your students can start taking and collecting data. It's a good chance to integrate graphing, and they can do different variables, so the amount of force applied versus how much it drooped, or you can even get into things like cost-benefit analysis of your bridge. And that cost could be tied to the mass of the object, so they're only given so many grams to play with to build their bridge, or it could be based on the complexity of the pieces, so you could actually assign arbitrary values to each of these pieces. So the students have to figure out the best way to use the resources they have. One of the other tests you can do with your bridges is actually testing their lateral capacity. Another material you can use if you are looking for a bridge that will actually break instead of just bend when you apply weight to it would be to use either lasagna pasta or fettuccine. With these, you use the nice flat-topped pieces that we have, and then slide using rubber bands and secure the pasta to the top of these flat-top pieces. Once you have that set up, you can then start applying weights. You'll want to do so, or encourage your students to do so, in a logical fashion. I can tell it's getting close to its breaking point, so I'm going to add just small increments. There's another 20. Another 20. Oh! And there it went. So that could carry 590 grams before the pasta piece itself broke. So, as you can tell by my reaction, it is a good way to get your students excited and invested in what they're doing. You can also have your students rise to different challenges. So maybe you have them each build a tower where they are given 12 of these standard stacking blocks and only 2 fancy pieces, and it's their choice which ones. And the challenge is that it must withstand the fan. The winner would be whoever can get their tower highest. And you know, students always like to have competitions and challenges, and then they can look at the designs that won, the designs that were sturdy. You can tie it into a lot of real-world buildings, a lot of real-world architecture, and have a good time with your students actually connecting this to things found out in the world and what they're doing in their physics classroom, what they're doing in their math classroom. And they're getting a chance to be their own engineers and troubleshoot and problem solve and maybe they get a chance to retry the whole experiment again based on more information. So however you're using this kit, whether you're building bridges and applying weights to them, building towers and adding fans, or just using the stacking blocks kit to explore patterns, compound frequencies, mean and median, and all these different math concepts, we've had a blast developing this kit and can't wait to see all the ways your students use it in the classroom.